In geometry, the term pseudosphere is used to describe various surfaces with constant negative Gaussian curvature. Depending on context, it can refer to either a theoretical surface of constant negative curvature, to a tractricoid, or to a hyperboloid. Theoretical pseudosphere. In its general interpretation, a pseudosphere of radius r is any surface of curvature -1, r2, by analogy with the sphere of radius r, which is a surface of curvature 1, r2. The term was introduced by Eugenio Beltrami in his 1868 paper on models of hyperbolic geometry. Tractricoid. The term is also used to refer to a certain surface called the tractricoid, the result of revolving a tractrix about its asymptote. As an example, the pseudosphere is the surface of revolution of the tractrix parametrized by it as a singular space. But away from the singularities, it has constant negative Gaussian curvature and therefore is locally isometric to a hyperbolic plane. The name pseudosphere comes about because it is a two-dimensional surface of constant negative curvature, just like a sphere with positive Gauss curvature. Just as the sphere has at every point a positively curved geometry of a dome, the whole pseudosphere has at every point the negatively curved geometry of a saddle. As early as 1693, Christian Huygens found that the volume and the surface area of the pseudosphere are finite, despite the infinite extent of the shape along the axis of rotation. For a given edge radius r, the area is 4 pi r2 just as it is for the sphere, while the volume is 2/3 pi r3 and therefore half that of a sphere of that radius. Universal covering space. The half pseudosphere of curvature -1 is covered by the portion of the hyperbolic upper half plane with y1. The covering map is periodic in the x direction of period 2 pi, and takes the horocycles y equals c to the meridians of the pseudosphere and the vertical geodesics x equals c to the tractrices that generate the pseudosphere. This mapping is a local isometry, and thus exhibits the portion y1 of the upper half-plane as the universal covering space of the pseudosphere. The precise mapping is where is the arc-length parametrization of the tractrix above. Hyperboloid. In some sources that use the hyperboloid model of the hyperbolic plane, the hyperboloid is referred to as a pseudosphere. This usage of the word is because the hyperboloid can be thought of as a sphere of imaginary radius, embedded in a Minkowski space.